Hello everyone. Today I'm going to show you the steps to solving exact differential equation using the second method. Okay, so the first step is to check for exactness. That is, you compare the result of the partial derivative of m with respect to y to the partial derivative of n with respect to x. If we can see that they're equal, then the DE is exact. That is step number one. Check for exactness. So remember that the form of exact is something like this: m dx plus n dy equal to 0. So you take the partial derivative of m with respect to y, take the partial derivative of n with respect to x, then compare the result. If the results are the same, then the DE is exact. So the next step, after that step, uh, after finding the exactness, then the next step is to find f. So find f, or the function of the two variables x and y, by integrating m with respect to x. Okay, that is the next step. That is, if you see here, our m is this one, then integrate that one with respect to x, then the result should be like this. You have here the result of integration of your m here, so you put that here, then plus. So we know that when we integrate, there is a constant of integration, but this time our constant of integration, we will use this f of y. Okay, so instead of we put c, we use f of y. So we have here integral of m dx, so we are holding y as constant. So our constant here is in terms of y, f of y. So you call that equation as equation 1. That is the result of step number 2. Okay, so call that equation as equation 1. Now, since we will be doing method 2 for this video, then the next step is to solve the same f. Okay, solve f again, but this time we have to use n. Now, a while ago, the second step, we use m. We integrate this. So, of the next step, step number 3, we have to integrate n with respect to y, holding x as constant. Okay? So, the result now, after the integration, like in step number 2, our constant of integration here is with respect to x. That's why we have here, after you integrate this n, you have the result here. Then the constant of integration is g sub x, because we hold x here as constant. So our constant here is a function of x. So let this be our equation 2. Then the next step, step number 4, we have to equate the two equations 1 and 2. So we equate them. Okay, so equating equation 1 and 2, then what will happen? So the result after step number 4, you have to substitute that in either 2 or equation 3 and equate f to c, or set f equal to c. Alright, so next we have here the example to demonstrate the steps. So solve the differential equation below. So we are given the same differential equation as in our previous video. Okay, so this is our m, this part here, the coefficient of dx, and this is our n, the coefficient of dy, and this is equated to 0. Okay, step number 1, we have to check for exactness. So we have to solve for our partial derivative of m with respect to y and partial derivative of n with respect to x. Then if we can find out that the two partial derivatives are equal, then the differential equation given is exact. Okay, so here's the test for exactness. So partial derivative of m with respect to y, holding x constant. So 2 is a constant, x a constant, so put that outside and take the partial derivative of y squared with respect to y. So this is a power formula. So 2x times, the power will go down, minus 1. Okay, then times the derivative of y with respect to y. So chain rule. And we have this result, 4xy. And do the same for n. Okay, but this time y is held as constant. Okay, so y is constant, so put the constant outside and take the partial derivative of x squared with respect to x. This is again power formula. So this part here, since y is constant, so the partial derivative of sine y is a constant, so sine of a constant is a constant, then partial derivative of a constant is equal to 0. So we have only this part. Okay, so power formula once again, so we get this. So you compare the result for xy also, so we can say that since the partial derivative of n with respect to x is the same, partial derivative of n with respect to y is the same as the partial derivative of n with respect to x, which is equal to 4y, then the given differential equation is indeed an exact differential equation. So let's proceed to step number 2. Step number 2 is to solve for f. No? Find f by integrating m. Okay, so by integrating m, our result must be something like this. Now, with respect to x, so y is constant, so we get this result. So our constant now is in terms or a function of y. Okay, f of y. Then we have here f equal to x squared plus y squared plus f of y. So call this as our equation 1. Then after that, let's proceed to step number 3. So step number 3, again, we have to solve for f, but this time we have to integrate n with respect to y. Okay? Then holding x as constant. So f is equal to the integral of partial derivative of f with respect to y, or equal to the integral of n dy. X constant. Okay? So we have this result after we do the integration. Okay, so therefore our f, so this is the result after our integration of y. So we have here f equal to x squared y squared plus cosine y plus g of x. This is our equation 1. So next step is to equate the two equation 1 and 2. So we have f, this is the value of f. We have f also, the value of f. So you equate the two equations and then we will get the result that we are looking for. Okay, so this is the result. This is the right side of our 1. This is the right side of our equation 2. So you see on the left side we have this x squared y squared. On the right side we have also x squared y squared. So when you transpose or subtract both sides by x squared and y squared, so we got only f of y on the left side, which is cosine y plus g of x. So therefore we can say that our f of y is equal to cosine y, but our g sub x is equal to 0. Okay, so we have here f of y, function of y, we have cosine, but we don't have g sub x. So that's why our g sub x is equal to 0. So the next step is to substitute the result to either 1 or 2. Okay, this is our equation 1, this is our equation 2. So substitute this information to either of these two equations. Okay, after you substitute, so we got this. If you substitute in 1, so we got this. If you substitute in 2, you got this. Okay, so let's continue it here. Yeah. So here we have f equal to x squared y squared plus cosine y equal to c. So we equate as mentioned in step number 5. Okay, if you can see step number 5, we have to substitute the result to 2 or 3 and equate f to c. So this is what we're doing here. Okay, so we substitute in 1 or 2 and then we equate f to c. So we got this equation, x squared y squared plus cosine y equal to c. Then as in method 1, we are given this initial condition, y of or f of x equal to square root of 2 over pi, then equal to pi. So this value, this is our x, this is our y. So substituting this here, okay, so we got c from here, we got c equal to 1. Then substitute the value of c in this equation, so we got x squared y squared plus cosine y equal to 1. So this is our solution. Okay, so that's it. That's how to solve the exact differential equation using the second method. So it's up to you which method you want to use, method 1 or method 2. So you will get or you will obtain the same result. So I hope you have followed our explanation and discussions. And if you have any question, just leave your questions or comments in the comment section below. Thank you.